Students, today we will discuss about electric field due to an electric dipole at a point on the axial line. Electric field due to an electric dipole at a point on the axial line. What's a dipole? Two equal and opposite charges separated by small distance constitute an electric dipole. Here AB is a dipole. Here minus Q and plus Q are two equal and opposite charges separated by a distance 2a. O is the midpoint of the dipole. Let us consider a point C at a distance r from the midpoint O of the dipole on the axis. And E plus and E minus are the electric fields due to the charges plus Q and minus Q respectively. Consider an electric dipole placed on the x-axis as shown in figure. A point C is located at a distance r from the midpoint O of the dipole along the axial line. E plus vector and E minus vector are the electric fields due to the charges plus Q and minus Q respectively. We can write the equation for electric field due to the charge plus Q. For that, let us recall the electric field equation. Let us consider the charge Q and test charge Q naught separated by distance r. Electric field E equal to 1 by 4 pi epsilon naught Q by r square, where r is the distance between the charges. Similarly, we can write the equation of electric field at C due to the charge plus Q. The electric field at C due to plus Q, that is E plus vector equal to 1 by 4 pi epsilon naught into Q by, what's the distance? Here the distance is r minus a, because from the midpoint the distance is r. So from the charge Q the distance is r minus a. So r minus a whole square into P cap. P cap is the electric dipole moment unit vector. P cap is the electric dipole moment unit vector. Its direction is from minus Q to plus Q. P cap is the electric dipole moment unit vector. Now similarly we can write the equation for electric field due to the charge minus Q. The electric field at C due to minus Q, that is E minus vector is equal to minus 1 by 4 pi epsilon naught Q divided by, what's the distance? Now the distance is r plus a. So r plus a whole square into P cap. Here the negative sign shows that the direction of the electric field is opposite to the direction of the electric dipole moment. That's why we put the negative sign. Now we can calculate the total electric field due to the two charges plus Q and minus Q. The total electric field at point C, that is E total vector, is equal to E plus vector plus E minus vector. Now we can substitute for E plus vector and E minus vector. That is 1 by 4 pi epsilon naught q by r minus a whole square into p cap minus 1 by 4 pi epsilon naught q by r plus a the whole square into p cap. Now take the common terms outside. Take the common terms outside. Q by 4 pi epsilon naught into 1 by r minus a whole square minus 1 by r plus a whole square into p cap. Simplifying, q by 4 pi epsilon naught, take the LCM, multiply the denominators, you will get r square minus a square whole square. Now we expand r plus a the whole square, r square plus a square plus 2ra. Expand r minus a whole square, that is minus r square minus a square plus 2ra. Cancel the terms. So q by 4 pi epsilon naught into 4ra divided by r square minus a square whole square into p cap. If the point C is far away from the dipole, if the point C is far away from the dipole, in that case R is much greater than A. R is much greater than A. So the A square term can be neglected. Q by 4 pi epsilon naught into 4ra divided by r power 4 into p cap. Cancel r. You will get q by 4 pi epsilon naught into 4a by r cube into p cap. Now what's the dipole moment? P is equal to 2qa, then 2p is equal to 4qa. Then 2p vector is equal to 4qa into p cap. So in this equation we have got 4qa into p cap. So we can substitute 2p vector. Therefore, E total vector is equal to 1 by 4 pi epsilon naught into 2p vector divided by r cube. So this is the total electric field. Now if the point C is on the left side of the dipole, the total electric field is still in the direction of the p cap. If the point C is chosen, on the left side of the dipole, the total electric field is still in the direction of p vector, because the direction of electric field is same as the direction of the electric dipole moment.